looking at chapter 2, part 3, the last part of chapter 2. Here we'll be looking at interpreting speed-time graph. Remember, in a speed-time graph, we said if you have a constant line in a speed-time graph, yes, speed. Okay, let me reduce the size of this one. Okay, in a speed-time graph, if you plot speed against time, for example, and you have a straight line, this is a constant acceleration. This is a constant acceleration. Okay, if you have this one, you have a constant speed. If it's like this, you have a constant speed, right? If it's like this, we have a constant speed. We have a constant speed somewhere here, okay? Now, we said if you want to calculate the distance traveled in a speed-time graph, you have to calculate the area under the graph. The area under this graph. So when we do calculate the area under this graph, then we are able to get the speed time graph. If you want the acceleration, we find the gradient of this straight line. We find the gradient of this straight line. The gradient of this straight line gives us the acceleration, while the area, calculating the area of this shape, gives us the total distance traveled in a speed time graph. So we need to remember where we get constant acceleration, which is this one, constant acceleration, and where we get change acceleration. Okay, where we have change acceleration. For change acceleration is when we have okay, something like this, and change deceleration, we have something like this. Okay, the speed time graph. Okay, so that's that for that. Now let's move on to when we talk about the gradient of speed time graph, it gives us the acceleration of the motion. Once you calculate the gradient, you find the gradient dy over dx, or y2 minus y1 over x2 minus x1. You will get the acceleration in the speed time graph. And when you find the area under the graph, you get the distance traveled. Okay? Now, interpreting constant positive acceleration on a speed time graph. Now, when the acceleration is constant and non-zero acceleration means that the speed is changing, it's increasing. Okay, it's either increasing or decreasing, but it's not you're not moving with the same speed. So when you're not moving with the same speed, the graph is a straight line, right? The graph is a straight line, right? Now the velocity is increasing at a constant rate. The velocity is moving at a constant rate, right? And we say the speed changes by the same amount in equal intervals of time. Speed will change by the same amount. That's the change in y over change in x. Remember, the x-axis is the time axis, and the y-axis is the speed axis. Is that okay? Now let's take a look at constant positive acceleration on the speed time graph. All of this, I think we've itemized them in part 2. So let's just go to the graph, okay? Let's say we have a speed time graph, constant positive, because the line is sloping downward and sloping upward from the bottom to the top. Okay, this is a positive gradient. You're going to get a positive gradient. Now, if you want to calculate the gradient, you can take as small as this triangle. As small as this triangle. Okay? As small as this triangle, we give you the gradient. We give you the gradient of, and the gradient is the acceleration. Okay? So when you want to do this, you say 5 minus 0, which will give you 5. 5 minus 0, which will give you 5. Then 20 minus 0, which will give you 20. 20 minus 0, which will give you 20. So if you do this, you get 1 over 4. 5 here, 1. 5 go here, you get 4. So 1 over 4 is 0.25. Okay, this gives you 0.25 meter per second squared. 0.25, you put the unit of acceleration. 0.25 meter per second squared. We put the unit of acceleration, meter per second squared. Not meter per second. Meter per second is for speed. Meter per second squared is acceleration. So we put the unit there. Now, this is on one hand. Someone might decide to make the whole of this one, but you will get the same answer as the triangle. The whole of this as the triangle. This whole, which is 10 minus 0, which is 10. 10 over 40 minus 0, which is 40. So 10 divided by 40, you get 1 over 4, you get 0.25. Someone else might use the whole triangle, the whole line graph, to plot as a triangle. Someone else. So that's how Cambridge will know whether you cheated, because everyone cannot be doing the same thing, even if you're taught by the same person. So a student might decide to use the whole as a triangle by saying 30 minus 0 on the vertical axis, which is 30, 30 minus 0, which is 30, okay, all over 120, 120 minus 0, which is 120. So if you divide this, you still go to get 1 all over 4. So this 0 cancel this 0, 3 to 3, you get 1. 12 divided by 3, you get 4. So 1 all over 4 is the same thing. So whichever way you do it, you get the same 0.25 meter per second square as the acceleration of the motion of the graph. Okay, but if you have to calculate in a speed-time graph, this is to calculate the acceleration in a speed-time graph. So acceleration is the gradient of this line, gradient m. So finding the gradient m in a speed-time graph, you get the acceleration. Is that okay? This is definitely in every Cambridge exam you're going to find. Now, if we are asked to calculate the distance traveled by this vehicle, this car, we find the area under this graph. And you can see the whole graph is a triangle. So you find the area. To find the distance traveled, you find the area. The area is equals to 1 all over 2. You know the formula of area of a triangle. 1 over 2 times base times height. Now, what is our base? Our base is this horizontal distance. Our base is this horizontal distance. Our base is this horizontal distance, which is 120. So our height is what? 30. Up to this place is 30 if you trace it to the values. So we just slot in everything to this place. We find the distance traveled by the vehicle. So we say 1 over 2 times the base. The base is 120. The base is 120. So we say times 120 times the height, which is 30. So when we do this, we're able to get the distance traveled by this object. The distance traveled by this object, whatever object it is. So we get 2 go here. We get 60. 60 times 30, we get 1,800. We get 1,800 meter. Okay, 1,800 meter. 1,800 meters. So this will be the total distance traveled by whatever object this is. This will be the total distance traveled by whatever object this is. Is that okay? So this is what it is. It is what it is. And let's move on quickly. So let's say we have another graph, say increasing positive acceleration in a speed-time graph. Okay. Now, if we have a curve in a speed-time graph, this means the acceleration is increasing. Just now, when we have a straight line, the acceleration is constant. Here, if you have in a speed-time graph, if you have a straight line like this, the acceleration is constant. This is a constant acceleration. The acceleration is a constant positive acceleration on a speed-time graph. Now, if you want constant negative, the line would have been like this. The line would have come down from wherever here, let's say from 30, that come down to this place. This would have been constant negative acceleration. This would have been constant negative acceleration if the line was like this. Okay, so we already know the positive and negative for a constant acceleration. Now, increasing acceleration is this one. When you in a speed-time graph, when we say acceleration is increasing, means we have a curve. We have a curve. So at every point you put a point, and you draw a tangential line. You draw a tangential line. At every point you put a point, you draw a tangential line, then you can calculate the acceleration, the increased acceleration. So here, any graph you see like this, there's a curve curving upward like this, it's an increasing acceleration in a speed-time graph. It's an increasing acceleration in a speed-time graph. Now for decreasing acceleration is when the curve protrude higher and then start to come down like this. This is a decreasing acceleration in a speed-time graph. Okay, so for this one, this is a decreasing acceleration. So whenever we have a curve like this, it's called decreasing acceleration. It's called decreasing acceleration. We can also calculate area distance traveled by calculating each small one, triangle and rectangle, 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 right? Triangle and rectangle. Then we add everything together. We get this total distance traveled. Okay, it's still possible to calculate the total distance traveled by this curve. Now this is also a decreasing deceleration. You know, when a line slows down like this, slope down is a deceleration. This is a decreasing deceleration. So when a curve is like this, it's a decreasing deceleration. When we have a speed-time graph that looks like an exponential decrease like this, that looks like this half-life, the half-life graph, the one that looks like that. This is called a decreasing deceleration. Okay, remember acceleration is when the graph is like this. When the graphs are either like this is called increasing acceleration, or this is called decreasing acceleration. This is called decreasing acceleration in a speed time graph. This is called a decreasing acceleration in a speed time graph. This one, speed time graph. This is decreasing acceleration, while this is increasing acceleration. This type of graph is called increasing acceleration. However, if it looks like this is called what? A decreasing deceleration. A decreasing deceleration. Now, in the case of increasing deceleration, okay, this is a decreasing deceleration. For increasing deceleration, it will be like this. Increasing deceleration will be like this. Increasing deceleration will be like this. While decreasing deceleration will be like this one. So in a speed time graph. Also for speed time graph. So we need to be able to understand this, because Cambridge, they ask you to describe the motion of the graph. They say describe the motion of the graph. So in Cambridge exam, they will ask you to describe, for example, if they draw a graph like this, they say you should describe the motion of the graph. This is a decreasing deceleration. This is a decreasing deceleration. Why this is increasing deceleration? Why this first two, this other two, this is increasing acceleration, why this is a decreasing acceleration. Okay? So they give you a graph in Cambridge. They ask you to tell or to describe the motion of the graph. Now, calculating acceleration. How do we calculate acceleration? In a speed time graph, we say we calculate the gradient. Gradient, remember, gradient is what? Change in y over change in x. Change in y over change in x. So gradient is change in y. Change in y means y2 minus y1. It means y2 minus y1. And change in x means x2 minus x1, right? So this is what we use. And remember, the y-axis represents the speed axis. The y-axis represents the speed. So final speed minus initial speed. Now initial here is 5. Okay, you can see if you trace it to this one, okay, and or you say initial is 40 because it's a deceleration. Initial is 40 and the final is 5. Okay, so 5 minus 40, you get negative. You know, deceleration, you get a negative number. You get negative 35 over 120 minus 0. 120 minus 0. So you get negative 35 for this particular graph over 120. That will give you your deceleration. Is that okay? So that will give you your deceleration. Okay, so you get negative 0.29. You get negative 0.29. That gives you your decreasing deceleration. Is that okay? Negative 0.229. Is that okay? So this is what it is for this type of graph. Okay, so Cambridge will be playing with you and will be asking you to calculate. When they ask you to calculate the acceleration in a speed time graph, they are simply asking you to calculate the gradient. Okay, we already learned this in coordinate geometry. We already learned this in mathematics coordinate geometry, how to calculate the gradient of a function. So let's move on, since we already know. Now let's take a look at the graph. Let's take a look at this graph. You say they've given us a speed time graph. They say A is the acceleration measured in meter per second square, right? And change in V, delta V is the change in speed. The change means that the final speed, whatever you got to as the final speed, minus the initial speed, the speed with which you started, for example. So you must have 2 points on the line graph. You must have 2 points on the line graph that you want to use to calculate your gradient. Okay? Each coordinate point is x1. You remember that in mathematics. Here is x1, y1, this coordinate point. x1, y1. Each coordinate point is x1, y1. And this coordinate point is also x2, y2. x2, y2. x2, y2. So here, once you know this, you'll be able to calculate what? You'll be able to calculate the gradient. By saying gradient is y2 minus y1 all over x2 minus x1. Okay? All over x2 minus x1, as the case may be. Now we move to the next one. Now this is for the case of decreasing acceleration. This is for the case of decreasing acceleration, this slope. So when you want to calculate, the big question is, if you want to calculate gradient for a curve, what do we do? You put a point in any part of the curve, you draw a tangential line. You draw a tangential line. Now you now use this your line to draw a triangle. You now use this your line to get a triangle and calculate. Get a triangle and calculate. Is that okay? You use this your line to get a triangle and calculate and get the value of the acceleration. Get the gradient of that straight line graph. Now we have a straight line. You know we have to have a straight line in order to be able to calculate, right? The gradient. So that's what we do. Is that okay? Now let's go to a working example that we elucidate, that we clearly state what this is. Now I say a cyclist is training for a cycling tournament. A cyclist is training for a cycling tournament. Now the speed time graph below shows the cyclist's motion as they circle along a flat straight road. As he circles along a flat straight road. This is a speed time graph. In speed time graph, when you're on the zero axis, the zero value, when you're on this zero value, it means you are still resting. You've not started cycling. So A means stationary. Point A means stationary. Point B now, he's circling, right? He's circling and moving with a constant acceleration. He's moving with a constant acceleration. To get that value, you have to calculate the gradient. You have to calculate what? The gradient. If you put a point here, if you put a point here and put a point on the zero, the gradient is, you trace this one here is 5. If you trace it here is 5. 5 minus 0, because if you trace this one here is 0. So you find the difference delta y, which is change in y2 minus y1. That's 5 minus 0, which is 5, all over. In case you are asked to tell the acceleration with which the cyclist was moving at point B. So you say 5 over. Now you check the values here. This one is 10 minus 5. 10 minus 5 is 5. So 5 divided by 5, you get 1. So the acceleration is 1 meter per second square. The acceleration is equal to what? At point B, is moving with a constant acceleration of 1 meter per second square. So this is a constant acceleration of 1 meter per second square. Is that okay? At point B. At point C, you don't say 0. C is not 0. In speed time graph, we say in moving at a constant speed. What's the speed value? We say 5 meter per second. The speed value is 5 meter per second. So at point C, is moving with a constant speed. So in the exam in Cambridge, they will ask you to describe the motion at C. Motion at C is a constant speed. Say constant speed. You write constant speed here. Here, he starts moving with a constant acceleration, and he has increased the acceleration even beyond this. If you calculate the acceleration in D, it will be higher than that of B. Why? Because it's steeper. It's a steeper slope. It's a steeper slope. So you say here is 10 minus 5, which is 5. 10 minus 5, which is 5. All over the difference in this way, 15 minus what's the value here? Here is 10, 11, 12, 13. Okay, here is 13. So we say 15 minus 30, which is 2. 15 minus 13, which is 2. So I say 5 divided by 2. You see I'll get my acceleration to be what? To be 2.5 meter per second square. 2.5 meter per second square. So you can see that he at point D is moving with a constant acceleration of 2.5 meter per second square, which is higher than the acceleration at point B. Okay, which is higher than the acceleration at B. The acceleration at B is 1 meter per second. The acceleration at D is 2.5 meter per second square. Now at E, it does not have acceleration. Acceleration is 0. In Cambridge, C and E, they can tell where the acceleration is 0. Acceleration is 0 at C, acceleration is 0 at D. Why? At E, not D. At E and C. Why is the acceleration 0? Because it's moving at a constant speed. Acceleration means rate of change of speed. If your speed is constant, acceleration will be 0. You know why? Because your vertical value will be 0. It's like you say 5 minus 5. You know, for us to get acceleration, we used to subtract the difference in the y-axis. Here you have 5 for initial, 5 for final. 5 minus 5 is 0. 0 divided by any value will be 0. So acceleration is 0 when you are moving at a constant speed. So in Cambridge, they ask you where is the acceleration? 0. Acceleration is 0 at C, acceleration is 0 at E. Okay, so we move on. So here are the answers they'll be given. Okay, so look at it. If it's asking you for the acceleration at B, Obviously, we've done that. 5 over 5, which is 1 meter per second squared, right? If it's asking you to calculate the acceleration of the motion of the cyclist at point B, you just do a triangle. You can do a triangle here. You trace this value here is 5, and this one is 0. So you say 5 here minus 0 divided by the difference in the horizontal value, which is 10 minus 5. 10 minus 5 is 5. So you say 5 divided by 5. 5 divided by 5, you get 1 meter per second squared. That's the acceleration at B, okay? So probably that's the only question they asked for that question. But I went further to explain the motion at B, acceleration at B, the speed here, the acceleration here is 0, acceleration here, we've explained everything. Is that okay? So let's move on to the next one. We say another work example. This motion is a decreasing acceleration. This is a decreasing acceleration. If the graph is curved this way, it's an increasing acceleration. If the graph is curved like this, it will be an increasing acceleration. If the graph was curved like this would have been an increasing acceleration. Okay, this one. But the graph is curved like this. So it's a decreasing acceleration. So you must know all of these things if you want to beat Cambridge to their games. If you want to beat them to their game. Now, a skydiver jumps from a plane and reaches a terminal velocity after 15, so they give you time. After T has been given to you. Time is after 50 seconds. So it reaches its terminal velocity after 50 seconds. Right? So now a speed time graph of the motion is shown, right? It reaches terminal velocity. When you reach terminal velocity, meaning you now have a straight line like this. Okay, let's erase this one that we drew. We can erase it, and so that we will focus on the real graph. Okay, so after that, when you reach your terminal velocity, your weight and air resistance will be equal. Okay, we're going to do that today also as our motion of free fall. Okay, you start moving with a constant acceleration, or a constant speed, or constant velocity. Now, I said the motion of the graph as below. Use this graph to find the acceleration after 5 seconds. After 5 seconds is here, so you trace it here, and you draw a tangential line. A line that will be target to that point. A tangential line. And then when you draw a straight line, you'll be able to now calculate the gradient based on this. Okay, let's see it. Look at it. You draw a tangential line at 5 seconds. Okay, at 5 seconds. And then you can now make your right angle triangle. Okay, you can now make your right angle triangle with this tangential line, with this line. Okay, so meaning you're choosing this point and this point for your gradient. Because we don't use the curve to calculate the gradient. We just draw a tangential line and then we calculate the gradient. Right? So gradient acceleration is changing y over changing x. So we read the value on the y-axis. If you trace this value, if here is 60, here is 58. This place is 58. So we say 58 minus, we trace the bottom value, 20. The bottom value is 20 here. So 58 minus 20 on the y-axis. Over on the x-axis, you trace this value down. It's less than 10, maybe 9 point something. It's very close to 10, 9.75. Minus, trace this one down, 0.75. Because here is, this box is 1.25 here. Because here is 2.5, so halfway is 1.25. Here is 1.25. So you'll be able to estimate the values. And then you slot it 58 minus 20 over 9.75 minus 0.75. You get 38 over 9, which gives you 4.2 meters per second. Now in Cambridge exam, they will give you a range in two significant figures. They will give you a range of values. They can say from 4 to 4.5. Any student will need that range because you are doing estimations of numbers here. So any student will need that range gets the answer. So this is how we calculate the acceleration. This is how we calculate the acceleration when they give you a curve. When they give you a curve, they will tell you at what point. If they don't measure, you choose any point you like. In the question, we mention where you should put your point to draw your tangential line. Okay? It says use the graph to find the acceleration at 5 seconds. So you have to go to 5 trace it here, put a point, use a ruler, draw a tangent, draw a line of tangent, then use the tangent to form any triangle you want, use it to form your triangle, and then calculate your gradient. Is that okay? So that's that for that. Now we're in the second part. Which is very important. This one is called the acceleration of free fall. Here we will be talking about terminal velocity. When you jump from aeroplane, you jump from a balloon, hot air balloon, you skydive, you jump from a height, and all of that. This is the acceleration of free fall. Now let's take a look at this. Okay, but before we go this, let's listen to a tutorial on this. Is that okay? Now let's listen.
This video describes the motion of objects as they fall towards the center of the Earth. What happens when a skydiver is in freefall? An object falling through a fluid, a liquid or a gas, experiences two forces, weight and friction or air resistance. The force of the air resistance acting on the skydiver increases with speed. Eventually, the air resistance equals the weight and the forces become balanced. This means the acceleration of the skydiver is 0 and they are traveling at the terminal velocity. When the skydiver opens the parachute, there is a sudden increase in air resistance, so the air resistance is greater than the weight. The parachuter does not move upwards. They continue falling to Earth. Do not be fooled by how it is filmed in the movies. This air resistance also slows the acceleration. The skydiver decelerates and eventually the forces balance out again and a new, slower terminal velocity is reached. Remember that all objects fall towards the Earth due to the acceleration of freefall, g, which equals 9.8 meters per second squared. The units are not newtons per kilogram, because this is for the gravitational field strength. This worked example asks you to sketch a graph of the changing speed or velocity of a parachuter as they fall from a plane to the ground. A suitable sketch that would score 3 marks should look like this. The first part of the graph shows that when they first jump out of the plane, the air resistance is small. We know this because of the small upwards air resistance arrow in the diagram. When the air resistance is small, the person will accelerate, so the gradient of the first section of the graph is steep. As the skydiver speeds up and continues to accelerate at g, then the air resistance also increases. Both these parts of the sketch correct will score 1 mark. When both the air resistance and the weight are equal in size, the skydiver briefly travels at a constant speed. This is known as the terminal velocity when their acceleration is 0. When the parachute is opened, the force of air resistance is instantly large. This causes the person to decelerate quickly. The gradient of this part of the graph must also be very steep to show this. These two sections of the graph correctly drawn will score the 2nd mark. Just like during the initial freefall, a constant terminal velocity is reached during freefall with the parachute. As you can see from the graph, this is much slower than before. This is to bring the skydiver to a safe speed, ready for impact with the ground. The final section of the graph shows an abrupt stop to a velocity of 0 when the person makes an impact with the ground. Both final sections of the graph, sketched correctly, give the final 3rd mark. In this question, you must compare the motion of an astronaut in space without air resistance to the motion of the skydiver with air resistance. An astronaut jumps out of the International Space Station, which is outside the Earth's atmosphere, but still within its gravitational field, without attaching his connecting wire. He falls towards the center of the Earth. Describe how the motion of the astronaut will be different to the motion of the skydiver until he re-enters the Earth's atmosphere. This is for 3 marks, so 3 points need to be stated in your answer. For the first mark, there is no air resistance in space. 1 mark. So the only force acting on the astronaut is weight. We know this because the astronaut is out of the Earth's atmosphere, but still within the gravitational field, so G will act on their mass. This gives the 2nd mark. Hence, the astronaut will fall with acceleration or increasing speed for the 3rd mark. Be sure to state 3 points in your answer. In summary, the motion of a parachuter in freefall towards the center of the Earth is described as follows. There are 2 forces, weight and air resistance or friction, acting on an object in freefall. Initially, the force of the air resistance acting on the skydiver increases with speed. Eventually, the magnitude of the force of the air resistance equals the weight of the skydiver, so the forces are balanced. This means the skydiver is no longer accelerating and they are traveling at a constant terminal velocity. Upon opening the parachute, the air resistance acting on the skydiver increases suddenly, slowing the acceleration but not moving the skydiver upwards. This causes the skydiver to decelerate. Eventually, the air resistance and weight balance out again to reach a new, slower terminal velocity. Don't forget to check out all our other fantastic revision resources here at Save My Exams.
Okay, so we've seen a Foley object, the motion of a Foley object, the force and everything, accelerations of the force, the weight, and so on and so forth. Now let's take a look at what we have. We say accelerations of free fall. You know, when object fall freely, first of all, we already know the meaning of acceleration, right? So acceleration is the rate of change of speed or rate of change of velocity. Okay, and then we say for free fall, objects falling from a height. For example, if you jump from a height, you have a free fall. You have a free fall. Oh, the only thing that will act on you, 2 forces. One is your weight, pulling you downward, and the air resistance that will pull you upward. Okay, so and the acceleration of free fall is approximately 9.8. But for Igcse, we approximate to 10 for convenience. 10, we approximate to one whole number, and that makes it 10. But the real acceleration is 9.81 meters per second square. Okay, and it's called G. This acceleration of free fall is called G. So when you jump out from a height, your acceleration value is 9.81 meters per second square. The acceleration, which is due to gravitational pull of the Earth. Okay, gravitational pull of the Earth, and we remember that the weight of an object is given as mass times the gravity, the gravitational pull. Okay, mass times the gravitational pull. So if you make G the subject, you have your weight. Your G is equals to your weight divided by your mass. Your weight over your mass. That will give you the value of this gravity. Is that okay? Okay. Now we know the unit of weight is Newton, mass is kilogram, and G in this regard is Newton per kilogram. In this regard, G is Newton per kilogram. Now let's take a look at the motion of Foley object, as it were. For motion of Foley object, a vacuum is a space that contains no matter. There's no matter in it, so there are no particles to exert frictional forces on the Foley object. So anyone that's out of the Earth's atmosphere, you are beyond the Earth's atmosphere, then there is no particles to carry out your frictional force on you, and so you're weightless. Okay. Now, when objects fall in a vacuum, there is no air resistance that's acting on the object. Okay, there's no air resistance or liquid resistance. So only the force with which you're falling, which is called your weight. The force, your weight, is the only force acting on you when you are out of the Earth's atmosphere. Your weight is the only force that's acting on you when you are out of the Earth's atmosphere. But according to Newton's second law, it describes acceleration as F over m. Acceleration of object as F over m, right? According to Newton, because F equal to ma from Newton's second law. F equal to ma. So from here, we can find the a, the acceleration. Okay, as a and g, they are similar. It's just that g is acceleration of free fall, objects that are falling, Acceleration is maybe G is like a deceleration, while A is like acceleration, okay? Because G is object going downward, that's acceleration, that's the G. A could be like you're going upward or you're going horizontally. That's the difference between them, okay? So if we say A is same as weight over mass, and we also say G earlier on, we say G is also weight over mass, then if we substitute one into the other, we have A to be mg over m. So if you cancel, because you already know the value of W is mg, mass times gravity. So instead of writing W, I replace with mass times gravity. So if we cancel mass and mass, you will see that A equal to G. Like I told you, they are both acceleration. Both acceleration of free fall or gravity, they are both acceleration. Is that okay? Okay. So now let's take a look at a falling object. Object falling with no air resistance. If you don't have air resistance, the only thing you have is your weight. The only thing, meaning you just be falling downward with a greater speed. You'll be falling downward with a constant acceleration. You'll be falling downward. So your graph will be like this if there's no air resistance. Your graph will just be a constant acceleration. You will be moving downward with a constant acceleration, right? So this will be object without no air resistance. These are objects that are out of the Earth hemisphere, out of the Earth's hemisphere, okay? But object falling with air resistance is different. The motion will be different, right? Because there's frictional force that will be acting on the object. There's a frictional force that will act on the object. There's also fluid or gases in the atmosphere that will act on the object that is falling. And there is frictional force that opposes the motion of the object as they fall. And even though it acts whether slowly or much more, but the point is there is liquid or gas that acts on you, there is frictional force acting on you, and so on and so forth. So this build up as you continue to move in the atmosphere, and hence a time will come, because if you're falling, you have two forces acting on you: the air resistance, which acts upward, air resistance, which is called frictional force in the air, and your weight pulling you down. So there are two forces. When they are equal, because when you jump out from aeroplane or from anywhere or from a height, the air resistance at the beginning will be very small, your weight will be higher. So you'll be falling down with a greater speed. So a time we reach, this one will be building up, this one will be like reducing till they reach the same value. When they reach the same value, we say you have reached your terminal velocity. You've reached your terminal velocity. So in Cambridge Igcse, they may ask you to define terminal velocity. What is terminal velocity? A terminal velocity is a velocity of a free falling object, a point where the air resistance of the object is equal to the weight. Okay? A point where the air resistance or the frictional force in the air is equal to the weight of the object. Okay? That's the terminal velocity. At that point, the object seems not to be moving downward or upward, but just floating. So all you need to do at this point when you reach your terminal velocity is to open your parachute. When you open your parachute, then you'll be able to decelerate slowly to the ground. You'll be able to start decelerating to the ground. So when you jump out, you know your parachute is let's say the aeroplane has a problem. They say everyone can now jump out. You jump out from the aeroplane. Your parachute, you wear it before you jump out. You have to wear it at your back. So when you jump out, you'll be coming down with high speed. You'll be coming down with high speed, right? You'll be coming down with high speed. And then a point we reach where your air resistance has built up. So your air resistance is now equal to your weight. So when your air resistance is now equal to your weight, then you have reached what we call the terminal velocity. You have reached terminal velocity. Here acceleration decreases because air resistance is building up. Air resistance is slowing you down. Since it's slowing you down, even though it's not equal to the weight, but it's slowing you down. Since it's slowing you down, your acceleration is decreasing. You're not accelerating fast. Here, when you jump out, you accelerate downward. So a point we reach, when you now reach your terminal velocity. When you reach your terminal velocity, you just be floating here. You will not go down, you will not go up. So at this point, your parachute has something like a whistle. You blow it. You blow your parachute, okay? It will open. Once it opens, you draw it. Not blow, you draw it. There's something you draw. You have to draw. It will open. Once the fluid is open, you will be like this, meaning you start to decelerate. You start to decelerate, meaning your change of velocity, speed will be decreasing. The change of speed will be decreasing till you are nearer to the ground again, where you experience another terminal velocity, and then you can touch the ground. So this is the different motion scenario. You jump out, you have only weight. When you are just jumping out, it's only your weight. But when you fully see air resistance is smaller than your weight, and then later on they build up, they are now equal. Your air resistance arrow is equal to your weight arrow. And then later on, when you open your parachute, air resistance will be bigger than your weight. That's why you are decelerating now. Okay, we're going to show you from the graph. Your air resistance is now bigger than your weight, so you are decelerating. Meaning your speed with which you are coming down is slowing down. Till you reach a point again near the earth, near the ground, both of them will be same again. When they are same again, you just open your parachute and jump down. Like just less than a meter away from the earth, okay? Okay, so this is the motion, what happens. Okay, we're not going to I'm not going to bore you with all these notes, okay? But I have described all the process. Now let's take a look at the graph. The graph showing the motion of the skydiver as they reach their terminal velocity. Let's take a look at the graph. So this is when you jump out of the aeroplane. This is the speed time graph of someone jumping out from falling from a height. Either you jump from an aeroplane or you are jumping from a height. So at first you see your weight is bigger than your air resistance, so your acceleration increases. To a point where here at first the air resistance is small, and then the person accelerates. Your acceleration is increasing. Now as the person speeds up, the air resistance also increases. As you are speeding up, just like we showed just now, the air resistance will increase. To a point where you will see that here it's like you have a constant speed. You know, this is a speed time graph. And here you have something like a constant speed. After a while, the air resistance balances the weight. So when the air resistance balances the weight, the person travels with a constant speed. Now this constant speed or constant velocity is called the terminal velocity. This terminal velocity for a while, then you open your parachute at this point, you open your parachute at this point. So in Cambridge exam, they may be putting letters here, describe the motion. They can put A here, they can put B here, they can put C here, and then they will be asking you a question. C is where you open your parachute. So at this point, you open your parachute, the parachute is open. Now there is a large upward force. The air resistance will now be bigger, so you are decelerating. Air resistance is bigger than your weight now, you are decelerating slowly, till you reach another terminal velocity again, where eventually the force, the air resistance and your weight becomes equal again, and then you take out your parachute and jump down. Then you get to this place. Here you take out your parachute. Okay, so if they label here as D, they label here as E. Here terminal velocity is about to happen. Here is F, terminal velocity. Here is G, the point where you take out your parachute. Here is when you jump to the ground, H. So Cambridge can draw a graph like this and ask any question they want to ask. And the description is what you see in every point, at every point. Or they ask you to draw the motion of a speed time graph or an object, a skydiver. Okay, a skydiver. Draw the speed time graph of a skydiver. This is what you're going to draw. Is that okay? Let's move on. I think once you know this, you're good to go. Here is a question for you. It's a small object falls out of aircraft. Choose west from the list to complete the sentences below. You have air resistance, gravitational field strength, air pressure, accelerate fall at a steady speed and slows down. The weight of an object is the product of its object's mass and is the acceleration of free fall? Okay, gravitational field strength. So we'll put gravitational field strength here, G, this one. So we say this one as our answer to A. Okay, when an object falls, initially it dash. Initially it what? It accelerates. So these are B answer. Initially it accelerates. So this is our answer. You write accelerate here. Write accelerate here. Okay? Then as the object falls faster, the force of dash acting upon the object increases. The force of the air resistance. So this will be our C. The force of the air resistance. So you write air resistance here. The force of the air resistance increases. The force of the air resistance increases. Now let's see the next one. Eventually, the object dash, when the force of friction equals to the force of the weight acting on it, it reaches terminal velocity, right, or steady speed. Okay, so since they did use the word terminal velocity, they use steady speed. So in some cases they use terminal velocity. So here you write here D. So you write the word, don't be writing A, B, C, D, just for the purpose of clarity. So you write here force at a steady speed, we write it here. So this is what we have for today. Thank you for joining us, okay? If there are more questions, please go through them, pause the video, try to answer the question. Thank you for joining us, okay?